Hello everyone, welcome to this video on nomenclature. We are going to learn about the IUPAC rules for naming an amide. Let us learn this rule and apply it in some of the examples. An amide is an organic molecule in which the carbonyl group, that is carbon bonded with oxygen through a double bond, is linked with an alkyl group on one side and NH2 group on the other side. We can understand its derivation from the carboxylic acid group, which is represented by RC double bond O OH. So if we replace OH with NH2, then we will get the amide group. Okay. Amines are the functional groups in which alkyl group is directly connected to NH2 group. However, in case of amide, we have a carbonyl group in between alkyl group and the NH2 group. Okay. To name an amide, we use this system. We name it as alkane amide, where alkane represent the carbon chain present in the molecule, including the carbon of the functional group. Okay, so we use the suffix amide to represent or indicate that this molecule is indeed an amide. And just like amines, we have different types of amines depending upon how many carbon atoms are in direct contact with the nitrogen. Just like that, we have different types of amide as well. The most basic amide will be the one in which nitrogen atom is linked with only one carbon atom of the functional group and two hydrogen atom. This will be called as primary amide. Now if we replace one of the hydrogen atom with an alkyl group, then nitrogen will be in direct connection with two carbon atoms, one of the functional group and one of the alkyl group. So this will become secondary amide, and likewise if we replace both the nitrogen atoms, then this will become tertiary amide. Okay, we will see example of each one of them. So let us move ahead and solve some examples. Let us have a look in this example. We can count the total number of carbon atoms present in this molecule beginning from the carbon atom of the functional group. So there will be a total of 4 carbon atoms present in this organic molecule, and we will use the respective root word to represent 4 carbon atom, which is bute. Okay, so bute will represent the 4 carbon atom present in this molecule. Then we will see the bonding between each carbon atom, which is single bond. So we will use the suffix "ane" to represent single bond. Okay, so we get the name of the parent chain, parent alkane, as butane. Now we will add the suffix amide along with it to indicate the functional group amide is present in this molecule. While adding both these two parts of the naming, we will omit this E right here, and hence the complete name of this molecule will become butanamide. Okay, where but represent the 4 carbon atoms, ane represent the presence of single bond between carbon atoms, and the suffix amide represent the entire functional group, that is amide group. Okay, let us do another example based on same set of rules. Now we have introduced a substituent. We have to mark the position of this substituent in this molecule. We will begin the positioning starting from the carbon atom of the functional group. So this carbon atom will always be marked as 1, then 2, then 3 and then 4. So this molecule will always be named as butanamide. Now we have a bromine group at the third position of this parent chain. So we will include its name as well in the prefix of the entire organic molecule name, and hence the name of this molecule will become 3-bromobutanamide. We have a bromine group on the third position of this molecule. Okay, let us see our next example in which we have included a methyl group attached directly to the nitrogen atom. From our previous discussion, in the case of amines, we will note that to position this group, we use the alphabet N and we do not need to specify any number. Okay, so we will count the number of carbon atoms in the parent chain beginning from this carbon atom as 1, 2, 3, 4. So this is again butanamide, and we have a methyl group on the nth position of this molecule. Okay, methyl group attached to the nitrogen atom. So we will write its position as N-methyl, and then the name of the organic molecule as we discussed is butanamide. So the entire name becomes N-methyl butanamide. Okay, so the new thing that we learned here is the substituent which is directly attached to the nitrogen atom is identified by its position using alphabet N. Alright, we do not need to specify any number. Now let us replace the another hydrogen atom with another alkyl group, ethyl. So we have an ethyl attached to the nitrogen atom. We have a methyl attached to the nitrogen atom. We will count the parent chain as 1, 2 and 3. So there are 3 carbon atoms. It will be named as propane. Okay, and to name it as an amide, it will be named as propanamide. Now we have an ethyl and an methyl. So we will arrange the name of these substituents in alphabetical order. The final name becomes N-ethyl, N-methyl propanamide. Thank you so much for watching this video. In our upcoming video, we will learn about the rules for naming carboxylic acid. So see you in the next video. Thank you once again.